All right, folks, it's officially 6 o'clock, so we're going to get going on this review. And just from my experience in working with it and having students take it, it doesn't take very long to go through it, especially if you understand it. And if you don't understand it, then you've got plenty of time to go through this, because this is essentially the same scope of material that you're going to get on your final exam. It's a review. So, same structure, the same more or less problem styles. May not be the exact same ones, and I know that can throw people for a loop, but this gives us an idea. All right, so now we're digging back deep into the end of the class, and this one another reason why this 020 is good at preparing us for the 120 is because we got to wake up all the sleepy blood cells in our brain that came about back in chapter 2 and chapter 3. Those things need to now be back and start circulating. This concerns the very first thing we talked about, a well-defined set. And so what we've got here is this guy's got a list of 200 people he invited to his wedding. He's got it in 3 different categories: family, friends, and coworkers. Each person gets into one category only. Now, after the wedding, he determined that 175 people attended out of the 200 he invited. The names of those who attended and those who did not attend were recorded in another list. Now, this is the only information that we have. We have nothing in here other than this, lists or rosters, so to speak. Now, let's go through each one of these, and let's look first of all and see if we can find the bad apples. Sometimes there's only one, sometimes there's 2, maybe occasionally there's 3. So here, the first one is the set of coworkers invited by Harry who did not attend. Is there a way for us to know by looking at his lists who's in that group? Y'all are awake out there, aren't you?
Yes.
Okay, good. Y'all had me scared there for a minute.
Cruz.
So then, yes to what? We can know who is inside of this. So we can click yes. Now, what about the next one? It says the set of people who attended that gave poor gifts.
No.
He does not have any information about that on there. Maybe he's got some kind of mental list, but he doesn't have it written down, so we can't go and determine what that is. Only if it's written down can we deal with it. You know, the idea of something being subjective and objective is sometimes not very clear, but this is a case where there are certain things maybe in his mind that he knows, but he doesn't have a list for them, so there's no way we can verify it. So this is a solid no. Now, doesn't mention anything about dancing, so what about this one? The set of people who attended who danced poorly at the wedding.
No.
There's nothing even in there about dancing. You know, maybe if there was a list with contest results, maybe, but this is no. The set of unpleasant people who attended the wedding.
No.
You see anything up there? No, he doesn't have that. Maybe he's got a mental checklist, but he doesn't have one that's well defined. The set of people who attended who were nicely dressed. Well, this is one of those where it's almost all of them. Most of the ones I've seen before were just like 1, 2, or 3. So, any questions about any of those rascals? Because I know we haven't seen these in a while, and that's why I wanted to make sure you went through that thing with the first half hour to get a good glimpse of it if you haven't already. Or if you have, then get a better glimpse of it and understand it. because we need to get a glimpse of what we don't understand. And that helps the lecture part go smoother because it allows you to ask questions.
I just got confused on the number 3 when you were when I was reading it. It just got me confused.
Well, then what you do, you have to read it again.
Okay.
That's the one thing I would tell you, because that happens to me. It's not something that's just foreign to human beings. I often read things and I don't have to understand it. So I just got to come back and read it again. I say, I understand this one, this and this one, but this one's got me like, my head going crazy. So read it again.
Mr. Cruz, that wasn't the last question on my number 1.
Well, these are different. Each time they do this, these are different. There's one with like bike racing. There's one with
Gotcha. Okay, I just thought it
something
was.
or else. Yeah, that's what I said. Is it's not going to be the exact same thing. Everyone's going to want to have one that's similar. What we would call an objective, and the objective here is to determine well-defined sets. That's the objective. All right. Now this one, it looks kind of complicated. It looks like there's 2 parts to it. But the good thing about this one is that you're being asked to find a set or the complement of a set given the set, and then you're asked the opposite thing. You're given the complement of a set and asked to find the original set. Well, the good thing about this is these are both the same process. Okay. You remember the complement of a set is just what's not in it. Now, the set that we're comparing it to is up here. All right. This is what we're comparing both of these sets to find the missing one. Okay. So now, what I like to do, handle this, is I like to go through here. I'm working on this one right here. All right. We're working on this one. Now, what I'm going to do is I'm going to go up here and take out the ones in that set I got here. So 1's gone, 3's gone, 4's gone, and 5 is gone. So that leaves me with, and we've got to open up the set thing here. If you just throw the number in there, burp, no good. You got to hit that set thing, and we put this missing one from up here. That right there is the complement. And why is it the complement? Because if we take those two, A and A complement there, and union them together, if we squish them together, then it ends up being the original universal set. That's what the complement is. They have no intersection. They're complete complements to one another. All right, so let's go on to the next one. So any questions about that one?
No.
No.
Okay. Well, does it make sense?
Yes.
Okay, so
Yep.
y'all follow me then on this next one. All right, so here's C, or C, a complement is 2 and 3. We're still using this universal set up there. So what do I need to do? What do I need to remove up here?
You
This
need
one?
to remove the 2 and then the 2 and a 3.
That's exactly right. Good work. So what happened? Oh, I think I clicked that disappear in the ink pen again. I don't know what good that's going to do anybody. So what's left over? And remember, you got to use this thing.
1,
And so,
4, 5.
1, and you got to have the commas. All right. So make sure you do that. What I'll try to do is because it's hard for you guys with being when we take exams and stuff. But sometimes I'll go through here, and if you forgot something simple like that, I'll give credit for it. But sometimes I may not get a chance to do it, and if I do it, I have to do it for everybody. So, but if you remind me, sometimes if you think you make a mistake like that, it could benefit selected people. Well, sometimes I think Alex takes off too much. All right. So, any questions about this process?
No, not that one.
Compliment.
Leave alone.
What's that? All right. So now let's go on to number 3. All right. This is that stuff that other stuff in chapter 2 that people tried to forget about. What do the two symbols mean? What does that symbol mean?
Union.
I'm the one that forgot.
Yeah, you got to make sure you got them straight. You can forget, but you got to remember it back. So basically, whoops. So when we started back in chapter 2, we talked about the union, and we used that symbol that looks like a U. In chapter 3, we start more explicitly talking about it as or, and then in chapter 10 with the probability, it's add. Okay? So that's the union. So what it means add both of those sets together. Okay? So what happens when we put them together? What's the first one? They don't have to be in order, but
-1,
yeah, but it helps.
0, 1, 2, 3,
2.
4, 5, 6, 8.
All right, is that it? So we got 3 in the top one, and then 1, 2, 3, 4, 5, 6. 6 in the bottom one. So that's 9 of them. 1, 2, 3, 4. Yep. Okay. That's it. You want to be sure you double check. I know there's a tendency to work fast, and there's nothing wrong with that, because if you kind of generally your intuition will be right most of the time, but you always want to come back and check. Go with your first instinct. Now, what does
I
this
don't see
mean?
nothing.
What?
I don't see nothing. That's the same.
What's the same?
And then in B, A and F.
Well, I'm not sure what you're talking about yet, but I'm getting ready to go to that.
Okay, let me see what you do.
So I gotta draw this thing because you can't really type this. All right, so that just means intersection
They have in common.
and then basically, and then in chapter 10, it's multiply. All right. So what we do here is just we look what's in this one and this one. What do they have in common? I had the funny feeling when I was doing this that they don't have anything in common, but
Yeah,
right?
right.
Right.
These are yeah, they have nothing in common.
You put this
Yeah, you put this.
Yeah, empty set. Okay.
It may accept this. Either one of those is technically correct, but to be safe, I'd use that one.
Okay.
And by all means, don't put both of those together. It's got to be one or the other. Because when you put that
It could
little,
be down. What's the other one? What is the other one?
or you can use this, just open and close it. In other words, like this.
Okay.
Look. Like this. Just basically that. That also means empty set. Since they've got that special symbol on there, I would use that one, but technically that means the same thing. All right. So number 4.
This one was
Okay, so let me type some important stuff up here. All right. And still I can't this is a crazy thing. It looks like a little pitchfork kind of thing. Like sort of like a funny looking E. It's an epsilon in Greek. And it just means is an element. Okay. Now the other thing that we see is this one. And that means is a subset. So let me just kind of explain this because everybody is having trouble with this in all the classes that I can see. In order to use the first one, you can be hearing a bare naked something like this here. Like I said, I can't select that Y, but that right there is a bare naked element. Okay, it's an element. It means it does not have any of the clothes on like a set does. So this is just an element without any brackets. It's an element. So this would be the correct one out of these two, because in order for this one to be true, you're not talking about Y, you're saying a set with Y in it, and you're saying it's an element. Well, that's not true. You would have to use, for this one here, for the second one, you got to use this rascal. The same thing here on B. They just got it kind of flip-flopped around a bit, but the top one is the set with a 2 in it is a subset of 2 and 3, and that's true because they're both sets. You do not use this one unless they are both sets. You have to have 2 sets. This one right here, use with the naked element. In other words, when I say naked element, if it's an element, of course it's kind of naked because it doesn't have the brackets around it. But that's what it is. You know, it's what makes it an element. It doesn't have any home inside. It doesn't have the clothes that the set does. So this one would be the true one here, because this one, the 2, doesn't have the brackets around it, so it's not an element. So it's not a set, it's an element. All right, so that's why that one's not true. All right, now down here on the C, I'm looking at this one first because here's the problem. This one looks a little bit more complicated, but I want to come back to this one because we've already done this up here and rejected that first one. I'm sorry. I guess we didn't. But anyway, this is what I'm saying here. You do not use the subset symbol unless you got another set over here. And we don't. We got the element. So it can't be that one. So let's go up here to that other one and see if that one looks halfway true. Well, it's saying T is not an element of R, S, and U. The T's are going out of there. There's no T in that right-handed set. And since the T has got no clothes on, then he's not in there. So that is true.
So basically, element doesn't have the brackets and subset does have the brackets.
Exactly. And that's
Okay.
why you can't use that subset symbol with an element and a set. They got to be used together. And like I said, is this one right here, you know, we just go past that so quick, the little pitchfork thing. But as long as you realize that you can't use it with anything unless it's got nothing around it, the no clothes on it, you know, that's the only time you would ever use that. Oh, let's see. So this one was the right answer because that is true. All right. So here, see the problem?
Yeah. Got clothes on it. The element.
Well, now, yeah, these got clothes, so it's not gonna. These aren't elements over here. That's a set. That's a set. So that doesn't work. So therefore, this one makes it true because they use the right symbol. All right, let's kind of get a move on a little bit. I want to kind of get through this whole thing. All right. So people forget about this, but this is also something that's throughout the whole course.
The fourth power.
But basically what it is, every time you add another variable, in other words, like with the counting rule, where you got 2 times 2 times 2 times 2. We looked at it with flipping coins. We looked at it with having children. Both of those are kind of the odd and even kind of thing. Well, it's the same thing with the subsets. Every time you add another element to a set, it doubles the number of subsets. Oops, I want to come back and put the in. All right, so let me write that. Boy, this is a pain in the neck writing that small. Anyway, that's an N, not a pi or anything. Okay, so then for this one up here, A has got C, Y, P, and T in it. So the number of elements in A is equal to 4. So that's N.
The fourth power.
So 2 to the 4th power,
4 times 2 is 8. 8 times
16.
16.
In other words, that's 2 times 2 times 2 times 2. And as I said, is the pattern is when you're taking powers of 2 like that, every time you increase that N, it doubles it. We saw that with the counting rule. Okay, but where do we put that?
B.
They're sneaky rascals. They change these around here, the order on them. It goes here, number of subsets. Okay, because that's what that formula right there is.
minus subtract 1.
Yeah. And I'm going to write that down. I wish it was here so you could write this down for me while I could keep talking. But subtract 1 to get the number of proper subsets. Okay. So then what's going to happen up here?
15.
We take out the one that's the equal. That's all it amounts to. Because a proper subset can't be is a set of itself. So like that's why the empty set can have no proper subsets. All right. All right, let's see.
So
So I
the
might, if it
you-
seems like I'm moving along faster, just ignore that and keep asking things. All right, so this is going back to
Mm,
the Venn diagram days.
mhm.
We still didn't get much out of the chapter 2, so we got a couple of truth tables in there to do. All right, so I know some people want some assistance on that, but this will be the last one for the chapter 2. All right, a survey of 337 college students were surveyed to see what they drank, coffee or tea. And then here's the both, and here's the neither. So how many of the students drink coffee? Well, it's just going to add up the ones inside of here. See that? That's what we're adding up. Because both of those drink coffee, right?
Right.
So 187. All right. So with this, how many of the students drink neither coffee nor tea?
73.
In other words, how many of them drink something else? Because what they're saying is how many don't drink coffee or tea. So these are the people who drink coffee or tea. So the ones that do neither are the ones out here. How many of the students do not drink both? Okay. Okay, here is both. There is both. And we don't want both.
So we add
Yeah.
196. You
Whoop,
gotta
what
take one of the ones off. Plus 77.
Oh, what happened?
Mm-mm.
So 342.
Huh?
Well, isn't that what it was? Or did when I typed it in there, did it put something in wrong?
What you add 73 to? No.
Did I edit twice? I wish I had the darn
You
Alex
said something. Do
calculator.
that again.
Yeah, let me do it again. This is what happens when I try to rush. Just ended up spending the same amount of time anyway.
Okay. You
269.
added 73
I
to
must
it.
have had it twice.
Okay.
So don't make that mistake on your test.
Okay, so you add these 73 as well.
Yeah, he did.
Well, okay, look. The one that's hash marked out is what you don't want it to be.
Mm-hmm.
So everything else. In other words, they're asking for the complement of both. So that's everything else. See, that's why I shaded that little section in to show you that that's the one we don't want, because that's the both. So if they're not both, they could be coffee only, they could be tea only, or they could have
I
none.
always leave out the one on the outside.
Well, that's what I'm saying is that's why I love the idea of shading these things. And I wish that, I don't know if Alex has got something like that or not. I know it doesn't for this because this is a problem from their thing. So All right. All right, so this is the truth table. Now, the good thing about this, it's just the basic ones for this class, and then 120, of course, they're going to be the ones a little bit more advanced. But P is there are monkeys at the zoo. Q is there are tigers at the zoo. There are no monkeys in the zoo, so that's the negation of what?
I'm sorry.
Monkeys at the zoo.
No monkeys at the zoo.
So there are monkeys at the zoo and tigers. Oops, what happened?
Put your hands-
And tigers. So here's your monkeys, here's your tigers, both of them at the zoo. And then this one is the or, and they want to, that's the disjunction. So that translates to or, and it's just opposite order. So we're looking for tigers or monkeys.
Tigers or monkeys.
Yeah.
I gotta freshen back up on my truth table.
All right. This is in the chance here because this one will be a little bit more. This is just the or and the and. So these are verbatim. So it's true,
True.
true, true,
False.
false. Does anybody want to explain why it's true, 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 false? Because I'm sure there's somebody that's got a question about it. Anybody got a good idea about why or is true, 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 false?
Mhm.
It really goes back to that union we was looking at. Okay, that union, if you're inside of the circles for coffee and tea, then you're in one or the other. The or, the union. The only time you're not in the union is when you're outside of the union. In the, the not area. So that's what that F is. Now the and this is just what we just looked at with that drawing. I forgot who was asking about it. About they said they had always forget to leave out the one outside. Well, that's what this one is, because this is the and. It's only that shaded region now. So this one's true, and this one is false, false, false. It's just the opposite of what we looked at with that Venn diagram, except it's done within the context of the truth table and, because that and is the same as the intersection and in the set theory.
Okay, run through that again for me.
What part? The or the and?
Both.
That could take years. Okay. All right, here we go. Let's see. Let me get a picture of a Venn diagram. All right. So here's looks like what we want. Something like this. All right. Okay, so with this, this is the union here. So this, if we're in the union, in other words, what we were just looking at with the or and the union are the same thing, then we can be here, 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 and there's our three truths, and there's the false that's on the outside of the union. Okay. Now, intersection. What happened to it? I thought it's open. All right. So on this, it's only true when it's in both. In other words, here is the only place where we're in both A and B, or P and Q, whatever you want to call it. See, we're in both. If we're outside in A only, that's false. If we're outside in B only, we're false. And we're outside here, we're false. And like I said, yes, for that little Venn diagram that we were looking at about the outside, everything that was not the shaded area, see, that's the ones that have the F in it. It was the complement of that. What's the answer on that one? Does that help?
Yep.
All right, because I'm kind of a visual person, so if I can bring
Yeah.
up something in picture to kind of help bring it together, that's what I'll do. Because I always had trouble, imagining things, I guess you could say, seeing what they looked like. But until you understand it well enough, I mean, you can just do it a bunch of times from memory, and usually there's enough, maybe 5 or 10 times, just kind of repeat the basic ones, and then when you get to them, you know them. Because if you just know the basic ones, you're all right. Now with this is an actual truth table that we got to build, and so we got this little thing on here to let us put in a column. And so
Extra column of P and Q. P then Q.
yeah, because see, we got a not P in there. So we got to put that in here. So all I'm going to do is just pick P over there and do the not of it, the negation of it. All right. And then I'm going to rewrite Q because we're using the little arrow thing. Order is important, and I'm always mixing stuff up if I don't, especially have to go fast. All right, y'all saw that. So now we've got the not P and the Q. Now we can just use the conditional rule, and the conditional rule is all. Let's see. I know I can bring it up, but we're getting close to time. What was that? Logic. Because I could chase it down in my notes. I thought I could get in the image quicker. But anyway, this is the truth table for the conditional. And I can do this with an image too. But it's a proper subset is all it basically is. I mean, that's what it relates back to, the idea of the proper subset. That's why this is the only one that's false. But anyway, see, we got to just follow them. And the conditional is the only one of these things, the operators, where order is important. So we got to remember to do that. So let's go back over there and I'll finish this out real quick. So that's true. This one's true. This one's true. But there's the false one down at the bottom. Let's see. I might be able to finish this real quick because we just went over these things. So this is just basically 4 times 1 times 2.
Yep.
This is the counting principle. You're not selecting anything. So they're just telling you got all these options. So if you put them all together, what's your package? Look, how many packages do you got? Vacation packages. So this is the one where you got to think about it. We got to establish order. So this is order matters, and this does not matter. All right, so this is the P here. That's P. And we're selecting 2, that 2 there from 5. And then this is the C, same thing. All right, so I'm just going to use the old Alex calculator. So this is 5 P 2 20. And then this is 5 C 2. So 10. So they're that simple if you recognize the order and the calculators on here. All right, so what last one? This is really pretty simple because it's taking us from basic probability into doing a conditional probability. And so if you follow it this way, it's really easy. And then we can go back and double check it a second way. But we need to know how many shirts there are because it wants the probability of a t-shirt.
28
So
divided by 70.
So 28. And then we've got 70 total. So then the probability of a shirt
20.
is 28 divided by 70. And the good thing about all these problems, in this one, they come out nice and even. You don't have to worry about rounding. Now, on this one, we're still going to use the 70 denominator, but we need to have
21.
parent and t-shirt. That's the and, see, the intersection. So then that's 21 divided by 70. Now, if we kind of remember our formula here, it makes it, it'll kind of make this easy, but let me just show you. All right, so this right here, the t-shirt, this means parent, given that it's a t-shirt. So the t-shirts are going to be in the denominator, and then both is going to be in the numerator. So it's going to be 0.3 divided by 0.4. Whoops. So that's 0.75. And we can verify this by looking at these numbers here. All right, it's given t-shirt. So that means the t-shirt is our denominator. And then the 21, is our numerator. Both of them using the formula, but it's just slightly different on how you're doing it. So see that? All right, I'll see you about in 15. So if you got any questions, just bring them up. Otherwise, I could probably finish the lecture for the whole course, but we'll see in 15.